Good morning, everyone. I'm Sangeetha B from the Department of CSE IoT working in SNS College of Technology. Today, we are going to see about process scheduling, operation on our process, and cooperating process and the CPU schedulings. Let me ask you something. When many students raise their hands in the classroom when the teachers ask questions, can teacher listen to everyone at the same time? The answer is no. The teacher, one who teaches, will be deciding first who should speak, and next who should be waiting, and next who will be speaking. In exact the same way, many processors want to use CPU. The operating system decides the order. Their decision making mechanism is called as a process scheduling. Today I will explain the process scheduling using the simple real life examples, not the complex theory. First, what we are going to see is what is process scheduling. Process scheduling is the core function of an operating system. It decides which process runs next, how long should it run, and when it should stop. Why is this needed? Because in a multi-programming system, many processes are ready, but only one CPU is available. So scheduling is about the sharing the CPU fairly and efficiently. Second one is why scheduling is important in real life with real life itself. Imagine in a hospital OPD, many patients are waiting. Some need emergency care, some need quick checkups, and some can wait. If the patients are not scheduled properly, emergency patient suffers, doctor becomes ideal, system fails. Similarly, without proper CPU scheduling, CPU may stay idle, some process may start, system performance reduce. So, the scheduling is required for better CPU utilization, faster response, fairness. And next, what is process scheduler? It is a big picture. Process scheduler is a part of an OS that selects the process, allocates the CPU type. Think of a scheduler as a traffic police officer, decides who move, who wait, who stop. There are three main schedulers: long-term schedulers, short-term schedulers, and medium-term schedulers. The first one we are going to see is long-term schedulers. The long-term schedulers decides which process should enter the system. Real life example is college admission office. Not all applicants are admitted. Only selected students are entering the college. Similarly, the process was selected from the job queue, moved into ready queue, control the degree of multi-programming. Important point is it runs less frequently. It is the slowest scheduler. In many modern systems, it may not exist. And next, what we are going to see is short-term scheduler, that is CPU scheduler. It is the most important one. It decides which ready process gets the CPU next. The real-time example is class teacher. Many students are ready. The teacher decides who answers the next. Short-term scheduler selects the process from ready queue, gives CPU to that process, works every millisecond, ensure no starvations. Important line is short-term scheduler is the fastest scheduler. The next we are going to see about the dispatcher, the executor. The scheduler only decides, but who actually gives the CPU? The job is done by the dispatcher. Dispatcher performs context switching, mode switching, control transfer. Real life example: movie director versus cameraman. Scheduler, director decides, dispatcher, cameraman executes. The time taken by the dispatcher is called as a dispatch latencies. Here is the example for dispatch latency. And next one we are going to see about a medium term scheduler. The medium term scheduler handles swapping. Real time example: classroom with limited benches. Some students are asked to wait outside. They are called back later. Similarly, some processes are removed from the memory, strong in the disk, brought back later. Purpose is to free memory, improve performance, maintain balance between CPU bounds and the IO bounds process. Other schedulers. IO schedulers manages read or write operations. reduce IO waiting time, real-time schedulers used in a system with the deadlines, example medical system flight control. They ensures tasks complete on time. Next one is the comparison is mentioned here. So in the conclusion, in this video we have seen about the process scheduling is what makes multitasking possible, system responsive, CPU usage efficiency. Every smooth operation is in your system is because the scheduler is doing its job correctly. So scheduling is not just a theory, it works silently every second inside your system. Hope you all understand. Thank you.